In early 2026, tech analysts viewed Sora as the inevitable successor to traditional film production. Major studios were already auditing their production slates to identify which human-led VFX teams could be replaced by Sora's output. This period of high anticipation ended abruptly. The financial validation of this shift was clear. Disney had committed to a partnership valued at over $1 billion, intending to integrate the model directly into their television and film pipelines. That momentum stalled on April 26th. OpenAI sunset the API, and the Disney partnership dissolved immediately. The public announcement followed a period of internal volatility. Several key executives, including the heads of marketing and AGI deployment, took sudden medical leaves just as the product reached its final testing phase. The departure of key personnel masked a deeper collision with physical infrastructure. OpenAI had reached the absolute edge of what current hardware can handle. Thermodynamic limits stopped the project well before the software reached maturity. To understand why, we have to look past the code and into the physical environment of the data center. The primary barrier was the VRAM Wall. Video Random Access Memory provides the high-speed workspace a graphics chip needs to calculate pixels. Because video generation requires the model to track motion across hundreds of frames simultaneously, it demands more temporary memory than most server configurations can provide. Silicon Valley has spent decades operating on the assumption that software can scale infinitely. Sora proved that even the most advanced code is eventually constrained by the capacity of a physical memory module. The unit economics of a 10-second video clip revealed a core problem. Rendering those frames costs $1.30. A $20 subscriber burns through that in 16 clips. Scaled across users, the daily burn reached $15 million. These numbers represent a massive hardware subsidy rather than a functional business model. Sora was essentially a research project, becoming too expensive to leave in the public's hands. Beyond the financial cost, the project faced a literal power bottleneck. Thousands of high-density server cabinets were required to keep the system responsive. This comparison chart shows the difference in energy requirements between text and video. While a text query uses about 0.34 watt-hours, a single Sora render can require up to 3,000 times that amount of energy. Scaling this energy draw threatens the stability of regional power grids. OpenAI found themselves needing more megawatt-hours than many data center locations could physically provide. This energy requirement forced OpenAI to operate as a heavy industry utility consumer, a role the company was not designed to fill. The company's infrastructure was locked into multi-year contracts for H100 chips. These physical circuit traces represent a legacy architecture that became a cage for the Sora team. Competitors like Google were already deploying systems like Neo 3.1, which utilized newer, more energy-efficient silicon to produce higher resolution output at a lower cost. With a public offering approaching, the $5.4 billion annualized loss generated by Sora became an impossible liability. OpenAI could not justify the massive capital expenditure required to replace their aging H100 fleet. In this hardware race, OpenAI's early lead became their greatest disadvantage. They were tied to the expensive architecture of the previous generation. The compute resources weren't actually destroyed. Following the shutdown, OpenAI redirected that entire server fleet toward an internal initiative codenamed Project Spud. Project Spud is the foundation for GPT 5.5. It represents a strategic move away from creative video generation and toward logical reasoning and autonomous software agents. The results on the SWE bench metric are significant. GPT 5.5 achieved an 88.7% success rate in autonomous software engineering tasks. Simulating logic is mathematically profitable. Simulating pixels is an energy-intensive luxury. OpenAI chose to prioritize the profitable simulation of an engineer over the unsustainable simulation of an artist. The sunset of Sora provides a clear indicator of the financial and physical risks inherent in brute force scaling. This physical silicon wafer represents the hard boundary of our current era. We have reached the point where simply adding more chips is no longer a viable path forward. The future of artificial intelligence is now being written within the constraints of our planet's resources, rather than the